오실로스코프는 자동 측정, 수동 측정, 점화파형 측정, 고장 증상별 측정이 가능합니다. 자동 측정은 33개의 센서 항목과 형식에 맞춰 시간값과 전압을 미리 세팅해 사용자가 쉽게 사용을 측정할 수 있게 구현하였는데요. 또한 고장 증상에 따라 자동으로 센서 항목이 고정되는 고장 증상별 측정 항목으로 사용자의 편의를 한 차원 높였습니다. 그 밖에도 8기통까지 측정 가능한 점화파형 측정 기능은 점화 2차 파형을 분할, 직렬, 기통별 등 다양한 화면 모드로 확인할 수 있습니다. 파형 분석은 한 번 들어서 쉽게 이해가 가지 않을 수도 있는데요. 여러 번 반복하여 숙지하셔야 손쉽게 장비 활용을 하실 수가 있습니다.
First, we'll take a look at how to connect to a vehicle. As shown in the figure, fit the groove of the scope cable into the device's protruded part of the scope terminal and then turn to fix it into place. Next, connect a probe to the signal line of the vehicle sensor to be tested, and then connect the ground clamp to the negative terminal of the battery or to the engine block. Generally, the electrical wiring of a vehicle sensor is composed of the power line, ground line, and signal line. The signal line is connected to the vehicle's ECU for signal transmission and reception. For tests using the oscilloscope, waveforms are confirmed by measuring the signal line. We'll learn about the basic measurement method. First, we'll go over channel activation. It is a function used to show only desired channels. Tapping when a channel is activated will hide the channel, and a subsequent tap will reactivate the channel. Change from AC to DC or vice versa can be done by tapping the AC icon in the channel configuration box. AC measurement function is only supported on channel 1. Also, if the normal character is tapped once in the channel configuration box, the mode gets changed to reverse and a subsequent tap returns the mode to normal. The second topic is adjusting the ground level. The ground level can be adjusted so that it's convenient for the user to view. Tap or drag the activated channel, which was activated by a tap, using the touch pen to set the location as shown on the screen. Third, we'll learn about how to set voltage. The user can tap the up-down arrows using the touch pen for the desired channel to increase or decrease the voltage. The range is from 20 millivolts to 50 volts. Fourth is on how to set the time. Using the touch pen, tap the left or right arrow to increase or decrease the time. The range is from 50 microsec to 10 seconds. Fifth, we'll learn about how to set a trigger. A trigger function allows display of repeating or intermittent signals in a way convenient for viewing on the screen according to trigger channel, voltage level, and screen location. First, tap on the trigger icon located on the bottom. Trigger for the desired channel can be selected by tapping on the corresponding icon. Tap the type icon to set the trigger as rising or falling. The mode icon can be tapped to select auto, normal, or single mode. The trigger level can be moved after tapping the level icon by using left, right, up, and down arrows. The trigger cursor can be moved after tapping the location icon by using the left and right arrows on the left side. Trigger settings can be changed by using the following icons located on the right as well. By tapping on the channel window, arrow shape, and mode text, the channel, type, and mode respectively are activated. Furthermore, if the Run Stop item is tapped, the screen that was paused by a trigger setup is reactivated. We'll learn about how to use the trigger using an example. We'll move the waveform shown on the screen to a location suitable for viewing. The pause icon can pause the screen, allow the user to save and analyze a measured waveform. Tapping of the reverse direction icon allows search of a saved file in the reverse direction. It is the pause icon. Tapping of the normal direction icon allows search of a saved file in the normal direction. Tapping the cursor icon allows measuring of time and voltage values of a saved waveform. If the file icon is tapped, the open and save icons are activated, which can be used to save the paused waveform or open another waveform for viewing. By tapping the open icon, a saved file can be loaded for analysis. By tapping on the screen icon, the screen layout can be changed. Tap on the icon that looks like the figure and change the mode to the basic waveform measurement. If the item shown in the figure is tapped, the screen only displays waveforms. If the plus item is tapped, each waveform's measured data values are shown in detail. By tapping on the grid item, the mode changes to the one in which screen configuration can be changed. Next, if this item is tapped, the screen layout is changed to the one shown in the figure. This item is the basic screen layout. If it is tapped, the dotted line on the screen disappears and only waveforms are shown. We'll learn about the auto measurement method of the oscilloscope. The auto measurement function automatically configures the division of voltage and time after selecting the sensors and sensor types to measure from among 33 sensor items, which allows convenient measurement without the hassle of setting additional configurations. As an example, we will do auto measurement by setting the crank angle sensor and the cam angle sensor. After selecting the angle sensor and the cam angle sensor, tap on channel 1 and channel 2 respectively. Next, tap on the save icon. Connect scope cables to the scope's channel 1 and 2. Connect the channel 1 probe to the signal line of the crank angle sensor, and connect the ground clamp to the negative terminal of the battery or to the engine block. Next, connect the channel 2 probe to the signal line of the cam angle sensor, and connect the ground clamp to the negative terminal of the battery or to the engine block. The waveforms will appear on the Carman Scan VG Plus screen. If the shapes or sizes of the waveforms are too small, adjust the voltage division, time division, or the trigger settings to make it convenient for viewing. Using the oscilloscope's manual measurement, we'll measure 3 waveforms in total. First is injector current measurement using an injector and a small ammeter. Go into the oscilloscope menu and select Manual Measurement. Double tap on channel 3 and 4 to hide them, and then adjust the ground level for convenient viewing. Next, connect the scope cable to channel 1 of the scope and connect a small ammeter to channel 2. We'll learn about how to measure the injector waveform using a scope cable. Connect the channel 1 probe to the injector's signal line and connect the ground clamp to the negative terminal or to the engine block. The next is on how to use the small ammeter. Insert the ammeter, which is connected to channel 2, into the injector power line in the right current direction. The range of the ammeter at this time is 100 millivolts per ampere. The following screen shows the connections of the injector and the small ammeter. Next, on the Carman Scan VG Plus screen, set the channel 1 voltage range to 10 volts, the channel 2 current range to 100 millivolts per ampere, and the time division to 2 microseconds. Finally, use the trigger level to set it up conveniently for viewing. The second is the waveform of the primary ignition and the current of the primary ignition using the ammeter. Go into the oscilloscope menu and select Manual Measurement. Double tap on channel 3 and 4 to hide them, then adjust the ground level for convenient viewing. Plug in a scope cable to channel 1 and plug in the ammeter to channel 2. Connect the probe of the channel 1 scope cable to the negative line of the ignition coil or to the collector of the power TR. Connect the ground clamp to the negative terminal of the battery or to the engine block. Next, insert the small ammeter connected to channel 2 into the collector line of the ignition coil power TR in the right current direction. At this time, the range of the ammeter is 100 millivolts per ampere. Adjust the voltage range of channel 1 on the Carman Scan VG Plus to 20 volts the voltage range of channel 2 to 100 millivolts, and the time division to 2 microseconds. Lastly, using the trigger level, set it up for convenient viewing. The third is cylinder power balance measurement using a large voltmeter. Go into the oscilloscope menu and select Manual Measurement. Double tap on channel 2, 3, and 4 to hide them and adjust the ground level for convenient viewing. After that, plug in the voltmeter to channel 1 of the scope terminal and connect it to the negative terminal of the battery in the right voltage direction. At this time, the range of the voltmeter is 10 millivolts per ampere. Now, set the voltage range of channel 1 to 200 millivolts and the time division to 100 microsec on the Carman Scan VG plan screen. The next is a screen measuring the secondary ignition of cylinder DLI type as an example. It is a typical example, so there may be some differences depending on the particular vehicle characteristics. Now we'll learn about the sequence in measuring the secondary ignition waveform. But first, looking at characteristics of scope terminals, channel 1 is for normal polarity measurement and channel 2 is for reverse polarity measurement. Lastly, channel 3 is for trigger pickup. The above characteristics apply when measuring ignition waveforms. When using the scope functionality, any channel from 1 to 4 can be used for waveform measurement as normal. First, enter the oscilloscope menu and tap on Manual Measurement. Then, double tap on the channel icon and hide all of the channels except channel 3. After that, lower the voltage range of channel 3 to 500 millivolts and set the time division to 5 microsec. Then, connect the trigger pickup to channel 3 of the scope. Take measurement for the first cylinder to the fourth cylinder in sequence, with the end with spark plug mark pointing towards below in accordance with the correct trigger pickup direction. At this time, if the waveform appears low, it's normal polarity, and if it appears high, it's reverse polarity. The difference in high and low is relative, so confirm it after the connection is made. After identifying the polarity of the 4 cylinders, connect the trigger pickup to the ignition cable of the first cylinder. At this time, if the first cylinder is of normal polarity, change the trigger pickup direction to have the spark plug mark pointing above. If the first cylinder is of reverse polarity, change the trigger pickup direction to have the spark plug mark pointing below, same as when identifying polarity. Connect the scope channel 1 set that picked up DLI. Channel 1 is of normal polarity, so connect it to the cylinder identified as being normal polarity. Connect the cable with a ground clamp among DLI pickups to the engine block or to the negative terminal of the battery. Connect the scope channel 2 set that picked up DLI. Channel 2 is of reverse polarity, so connect it to the cylinder identified as being reverse polarity. Connect the cable with a ground wire among DLI pickups to the engine block or to the negative terminal of the battery. Return to the Carman Scan VG Plus screen and go to the ignition waveform measurement mode in the oscilloscope menu. First, select the cylinder and then select the ignition cylinder. Then select the probe type and tap on the Save icon. This concludes explanation of an example that applies to the 4-cylinder DLI type. DLI polarity identification and connection method for 6 cylinders and 8 cylinders is the same as for 4 cylinders. However, when selecting the ignition cylinder, change the per-channel characteristics before proceeding. As shown on the screen, the left side selection window is for channel 1 and the right side selection window is for channel 2. Select the polarity to change. Next, change the probe type and save the settings. We'll take a look at the menu of the secondary ignition waveform measurement graph. Among the icons located on the bottom, there is the voltage configuration icon for changing the voltage axis. Using the cylinder icon, a desired cylinder can be expanded for viewing. The pause icon can be tapped to temporarily pause waveform measurement, which allows analyzing the measured waveform. The screen configuration icon allows viewing of the secondary ignition waveform screen in partition, series, per cylinder, trend, 3D, and 720-degree mode. Here, the partition mode divides up the screen into top and bottom portions. On the top area, the overall waveform of the cylinders is displayed, and on the bottom area, a waveform for each cylinder is displayed. The ignition waveform screen is set to the partition mode by default. Next, the series icon displays the overall ignition waveform of the cylinders, and when an icon associated with a cylinder is tapped, that cylinder's waveform is displayed. The trend icon shows the overall trend of ignition waveform values. Here, if the peak voltage is tapped, peak voltage data window gets activated on the right. If the dual time is tapped, the dual time data gets activated. If the combustion time is tapped, the combustion time data window gets activated. And if the combustion voltage is tapped, the combustion voltage data window gets activated, which shows changes in the values of each cylinder. For waveform measurement by trouble type, when a trouble type is selected, the sensors related to the trouble type are automatically selected and ready for measurement using the oscilloscope. At this time, if the user saves after selecting a trouble type, sensors related to the trouble according to each channel are selected, and the mode changes to scope measurement. For example, we'll measure the grinding while starting up trouble among startup troubles. Select Grinding while starting up and tap the Save icon. Connect scope cables to the channel 1 and 2 of the scope. Then connect the channel 1 probe to the signal line of the crank angle sensor, and connect the ground clamp to the negative terminal of the battery or to the engine block. Next, connect the channel 2 probe to the negative line of the ignition coil or to the collector line of the power TR, and connect the ground clamp to the negative terminal of the battery or to the engine block. Waveforms will appear on the Carman Scan VG Plus screen. If the shapes or sizes of the waveforms are too small, adjust the voltage division, time division, or trigger settings for convenient viewing. Meter and Simulator performs functionality of a multimeter and does simulation. We'll explain about the most commonly used functions, namely voltage and current measurement and resistance measurement. Go into the oscilloscope menu and tap on Meter and Simulator. Looking how to measure voltages, plug in a scope cable to channel 1. Connect the probe to the desired measurement point and connect the ground line. Then tap on the voltage icon to confirm the measured value. On the voltage measurement screen, graph measurement range can be changed by using the up and down arrows located on the left. Furthermore, the channel to measure from can be changed by tapping on the channel measurement icon. Also, the reset icon can be tapped to reset to default min-max values. Next, we'll look at how to measure the current. Plug in an ammeter to channel 1 and insert it into the measurement point in the right current direction. After that, set a suitable current range in the current measurement screen. For current measurement as well, the channel measurement icon can be tapped to change which channel to measure from. Lastly, we'll learn about how to measure the resistance. After plugging in a scope cable to channel 1, tap on the Set 0 icon in the resistance measurement screen and connect the probe as shown in the figure on the screen. Tap on the Start icon to begin the Set 0 process. After setting the 0, connect the probe and the ground line to the area to measure. Confirm the resistance value in the resistance measurement screen. Resistance measurement is only possible on channel 1. Furthermore, using the reset icon, min-max values can be reset to default. For starting an actuator, output is only possible on channel 4, and voltage output and periodic frequency output is only possible.